All right, so pre-calculus 20, we're at section 2.3 here, and we're going to talk about the sine law. We're going to split 2.3 into two parts. I'm going to talk about the sine law. Now, in math is about recognizing patterns and generating formulas and equations and using these patterns, right? So we can solve other problems that are related or similar. So there are lots of laws in math that we're going to study, and I want to talk to you today about the sine law. So I think we talk about this as well in pre-calc 30 as well, but this is where it's introduced. This is the big one. Sine law and cosine law, we talk about it here. So sine is one of the trig functions, okay, so we know that, and this law is going to be involving the sine ratio, okay? So let's just move here to, let's move to our notes over here. Okay, so I asked you to draw this triangle here at the beginning of class. If you haven't drawn that yet, draw one that's similar. Now this is not a right triangle, okay? Not a right triangle. So B is not a 90 degree, although it might look like a 90 degree, B is not necessarily a 90 degree. And so the sine law is going to come into effect especially to help us solve for different parts of a triangle when the triangle is not a right triangle. So you might think, well, how do we use sine if it's not a right triangle? Well, it's a good question. But the sine law is applicable to all triangles, not just right triangles. So that's why it's really useful. That's why we need to study it. Okay. So I'm going to set this up. First of all, there's my text. May as well grab my text out. So first of all, this triangle, you need to label the angles ABC. It doesn't really matter which is which, but it'd probably be helpful if you labeled yours similar to mine. And also notice that sides that are opposite angles are like the lowercase version of the angle measure. So notice I have capital A, or uppercase A right here for this angle, and lowercase a as the side that is opposite, okay? So that is a convention that we will use throughout here. Okay? So what we're going to do is we're going to develop the sine law a little bit here. So I'm going to show you how this comes about. So this may or may not, a light bulb may or may not go on when I first talk about this, but if you think back to this, or if you watch the video again or whatever, it might make a little bit more sense kind of as we move through this. So what we're going to do is we're going to drop a altitude here, which means from this point we're going to drop a line straight down so that it forms a 90 degree angle. Two 90 degree angles, and in doing so we have two right triangles. Okay, so again, this is just developing the sine law. We're going to label this H for height, I guess. Okay? So in doing this, we're going to focus on angle A and angle C here. Okay? So what we can look at now, and you don't have to highlight this, but I'm going to highlight this right now. The first triangle looks like this. It's a right triangle that has angle A over here and side H over here. Okay? And C is the hypotenuse for this highlighted triangle. Everyone see that? So when we look at that, we can write the sine ratio for A, and that's going to equal opposite side, which is now H, because remember, you can take the sine ratio for right triangles. So the sine of A equals H over, that's opposite over hypotenuse. Does everyone see that? Okay. That's step number one for that triangle. Now I'm going to use a different color to highlight the second triangle because we're going to focus now on angle C. So here is the second right triangle that we've formed there. Everyone see that? So what can we do? Well, the sine of angle C equals, well, same thing. It's opposite side, that's H, over hypotenuse. And in this case, that is the full side A. So again, where are we at? With any triangle, you can drop an altitude down from the vertex, let's say that the vertex that seems to be at the top, drop a 90 degree, a perpendicular line down to the base somewhere. You've got two right triangles. Now you can look at the angles here that are on the bottom of the triangle, A and C in this case, and you can write a sine ratio for each of those involving H and the sides A and C. So that's what we've done so far. Okay. Now what you want to notice is that the height of this triangle, that is the length of H, is the same in both equations here. Okay, we're talking about the same H. It's the same side, the same length. So if you have two equations and parts of each of those equations are the same thing, we can now isolate for h, and watch what happens. So h, I'll do this in block now, h equals c sine a. Everyone see that? I've just cross multiplied there, yeah? And over here, h equals what? A sine c. So now we have two equations, or we have two expressions, like c times sine of a and a times sine of c. They both equal the same thing. So if you have two things that equal the same third thing, that means that those two things are also equal to each other. Okay, what's that? The transitive property, I think. If A is equal to B, and B is equal to, or if A is equal to B, and A is equal to C, then B is equal to C. So if two things are equal to the same thing, then those two things are the same. Okay. What that means is we can set up now a third equation that goes like this. C sine A equals A sine C. And we're getting very close to the kind of a part of the sine law. So now what we want to do is we want to manipulate this equation in such a way. First of all, I'm going to divide both sides by sine A. And then I'm also going to divide both sides by sine C, and it's going to look a little bit like this, and I'll just make some space and finish that for you. So after we've manipulated this equation, we're going to see that we have this, and this is going to be very easy to remember, first of all. And it's also going to be, we could do this another time, and we could have c over sine c. We could do the same thing with the triangle, except have it rotated a bit, and we could do this. It's going to end up to be equal to b over sine b. And so in this case, if we were to do this again, we could see that we have three ratios that are equal to each other, and that's what the sine law says. Okay? So here's the sine law. This is kind of what we've worked on developing here, the sine law. It says that in the sides of a triangle, that is any triangle, are proportional to the sines of the opposite angles. That means this, and this is going to be easy for you to remember right here. So the sine law is this: A over sine A, that ratio, is equal to B over sine B, which is also equal to C over sine C. That's the sine law. So we're going to be able to use any two kind of pieces of this to make an equation, a proportion, and we're going to be able to solve for some missing pieces here. So I'll give you a second to jot this down and to just kind of read that. It's in your textbook as well, on page 102, and then we'll do some examples. Okay, so let's take a look at example 1 in the textbook. Again, we're going to use the sine law. The sine law says that we can have ratios, and notice that, guys, notice that the ratios could be flipped as well, right? If you take the inverse of an equality on both sides of the equation, that's also equal. So this is sort of the way you might remember it, but this is also true as well, that you can have them in the inverse situation, okay? So this is good too. Either way, both the same. So how do we actually use this in a question? Okay, so notice in this question we do not have a right angle triangle, so we can't use sine, cos, or tan just straight up like that. So let's read it. Pudluk's family and his friend own cabins in the Kalit River in Nunavut. Pudluk and his friend wished to determine the distance from Pudluk's cabin to the store on the edge of town. They know that the distance between their cabins is 1.8 kilometers. Using a transit, now a transit is it's a tool that measures distance very accurately. Using a transit, they estimate the measures of the angles between their cabins and the communication tower near their store, as shown in the diagram. Determine the distance from Pudluk's cabin to the store to the nearest tenth of a kilometer. Now this may be Pudluk's cabin over here. I'm not really sure. That looks like this is what we're talking about. Okay, way up in Nunavut. So here we have this situation, and we're asked to find the distance from Pudluk's cabin, that's A, to the communication tower, I guess, to the store, friend's cabin, Pudluk's cabin, communication tower. Near the store. Okay, so we're basically we're finding this distance right here, I guess. Okay. Everybody good with that? You understand? So in this triangle right here, can we use the sine law? Now, notice that we can use any two ratios in the sine law. Well, we're not going to use all three of them. Don't use all three of them. That's just awkward. You just use two of them at a time. Okay? And it doesn't matter what's A, what's B, what's C, really. But I guess this would be little c over here, because this is labeled C. And what we're trying to find is little b. Right? We don't know what this is. So in order to use the sine ratio, okay, so here's a little tip for you that you will uncover, but I'm going to let you know right now. In order to use, you have to have at least one pair of an angle and its opposite side that's given. Okay? So we do not have the angle here given. We do not have the side here given. And we do not have the other side here given. So right now, we need to step back and say, okay, is there any way that I can solve from what I know a pair of angle and its opposite side length? So really, I need either this side length or I need this angle to be determined. Do I have enough information to solve for either of these two things? The answer is yes, and who wants to give me the answer? How would we do that? Which one? Yep. Okay, very good. All of the angles of a triangle have to add up to 180. That's a property of triangles. And we have two angles, so we could solve for the third really easily. So yeah, so let's solve for angle C. That's perfect. Angle C equals 180 minus 88 minus 61. Everybody see that? So angle C is, what is that? 22, 31? 31 degrees. So angle C is 31 degrees. Okay. Now we have a pair. We have an angle and its opposite side measured. And look at what we can do now. I can say 1.8 at side C over the sine of angle C, because those have to go together. And I can let that equal to another pairing. Well, I know I have 88 and I want to find B. So guess what? Let's go B, that's the unknown part, over the sine of 88. So we're using two of the ratios in the sine law, and we have three of the four quantities. They are known, and we can always solve for the missing one. If we have an equation and we have one unknown, we can always solve for that one unknown. If you have two unknowns, like we had just a few minutes ago, if I didn't know this one and you went, okay, so this is what I'm going to do, 1.8 over the sine of C equals B over the sine of 88. If you tried that, you have two unknowns, and you can't solve for both of them at the same time. So you got to ask yourself, okay, can I figure out one of these because this is not good? And of course you can. All right? So simple cross multiplying, dividing if you need to. So B is actually equal to 1.8 times the sine of 88 over the sine of 31. Everyone see that? That's what B equals. So on your calculator, you just go ahead and get your calculator open out here, and you go 1.8 times the sine of 88. Hopefully you're on degrees and not radians in your calculator. Divided by the sine of 31. And I often evaluate the numerator first, hit equals, and then do the denominator, just so you don't get into any weird order of operations things. So this looks like it should be B. Now I'm just going to make sure I'm on degrees. Good, degrees, not radians. And so 3.49, or B should be about 3.5. Now is that reasonable? Is that reasonable? This is 3.5. That's what we figured out. So if this is drawn to scale, that looks like it could be true. Almost twice as much as this one. Right? So that looks like it could be true. That looks like it could be reasonable. And we have the luxury of having the answers in the text. So if we go back to the text, and here's the example. Method 1 ignores the sine law. So I didn't do method 1. See, method 1, they basically set it up like we did before to prove the sine law. So method 2, using the sine law, is definitely the easiest way to go. And that's what we did. So about 3.5 kilometers, that's the answer to the question. So 3.5 kilometers. Okay, any questions about example 1? All right, so this is the end of part 1. As I said, the key ideas, here's the first few key ideas from the section that we tackled in part 1. The sine law looks like this right here, or it looks like this right here. They're both valid. And you can use any two of these ratios to solve for a missing part in a triangle. To use the sine law, really, we need two angles in one side, or you need two sides and an angle that's opposite one of the given sides. So you can read through that, and you can understand, just like that example 1, that we had to do a little bit of work ahead of time to set up the sine law. But okay, so you can work on 1, 2, 3, and 4 from your text here.